In this video, we'll do matrix inverse and its properties. First, we assume all the inverse are exist. So I mean, like, if I put A or B or C matrices, they have to have inverse. First, A inverse is a unique. I mean, like, if you have A inverse, it has only one inverse. So there is no other than this inverse. For example, let's say let A equal 1, 2, 3, 4. And we know before, let's change the color. We know before, if you have A, let's say you have A, B, C, D. If it's 2 by 2 matrix, we have a formula. So here A inverse equal 1 over the determinant of A multiplied by this matrix, which is swap these two elements. So it will be here D and here A, and you have to put negative B, negative C, negative B, negative C. And if I want to write it in another way, so the determinant of A, which is A multiplied by D minus B multiplied by C. So I will write it like this: A multiplied by D minus B multiplied by C. And this matrix remains the same. So D, negative B, negative C, A. And of course, you can put 3 by 3, 4 by 4 matrix, whatever you want, and you will get A inverse. Of course, in your way to find A inverse, but A inverse, it always has a square matrix. So it cannot be 2 by 3 or 5 by 4 or 7 by 3. So it has to be a square matrix. So if you want to find A inverse, it has to be a square matrix: 2 by 2, 3 by 3, 4 by 4. So if you put 3 by 4 matrix, so the size 4 by 5 or 3 by 2, you cannot find the A inverse. So let's say here, as I said, assume all the inverse are exist. If you want to find the inverse of this A, let's change the color first. A inverse equal, you have to multiply 1 over 4, which is 4, minus, you have to multiply 2 multiplied by 3, which is 6. Then the matrix here, you have to swap these two elements. So it will be 4, 1, like what we have done here. Then negative 2, negative 3, negative 2, negative 3. So this equal 1 over 4 minus 6, which is here negative 2. So it will be negative 1 over 2. Negative 1 over 2, because here 4 minus 6, negative 2. So I put negative up, which is here, and here I make 2. Now let's write this again. 4, negative 2, negative 3, 1. Now if I insert this negative half on each element, so negative half multiplied by 4, which is negative 2, negative half multiplied by negative 2, which is 1, negative half multiplied by negative 3, which is 3 over 2, negative half multiplied by 1, which is negative 1 over 2. So this is the A inverse. Now you can see here this A inverse, it has only this elements. So if I told you this also A inverse of this A, you will tell me no, it's only this. It's like you have a unique fingerprint, a unique eye print, unique blood. So anything you have a unique, no one like you. So it's like this. So A inverse here, this A inverse, only inverse to the original matrix, which is A. Second property, let's change the color. A inverse power inverse, which is, you can see it here. So if you multiply -1 multiply by -1, you will get 1. So that's why here A. So if you put the inverse of the inverse, you will back to A. Now let's give you example about this property. Let A equal the same as here. I will always use this A in this video. Of course, you can put any matrix, but I will stick with this A. 1, 2, 3, 4, and we have already computed A inverse, which is this one, -2, 1, 3/2, -1/2. Now, if I put the inverse of this A inverse, I will back to this A. Let's try it. So A inverse, power inverse. So I will put this A inverse. So the inverse of this. So as we did here, so this multiplied by this, 1 over -2 multiplied by -1/2, which is 1, minus 1 multiply 3/2, which is 3/2. Matrix here, I have to swap these elements. So -1/2, -2. Then I have to put -1, -3/2. 1 minus 3/2, which is -1/2. Here, this one, it will be -1/2. And we know if we have in the denominator -1/2, the 2 will go up. And here we have negative, so it will be here negative. And this, it will go up, it will be 2. Then I have to write this matrix. Negative with negative, it will be positive. 2 multiplied by half, which is 1. Negative with negative, positive. 2 multiplied by 1, which is 2. Negative with negative, positive. 2 multiply 3/2, which is 3. Negative with negative, it will be positive. 2 multiplied by 2, which is 4. So we back to A, our A. Here, our A. So you can see how we visualize this property. So if you put the inverse of this A inverse, you will get back to A. 3. If you have R multiplied by A and the whole thing inverse, you will get this here. R is scalar, so any number, I mean, not matrix, a number. So if you have, you will get 1 over R A inverse. So A inverse, it will go here. R not equal to 0. R belong to the real number. Let's go down a little bit. Now let's give you example about this. If you have, let R equal, for example, 2, and let's put A and A inverse here. I will speed it up to write them. So now if I want to illustrate this property, let's write it here 2 and A, which is here. Let's write it 1, 2, 3, 4. If I want to take the inverse of the whole thing here, equal, so this scalar, it will go down, so it will be 1 over 2, and this, the inverse of this, it will be here. So you can see here this number 2, it's like power -1, so it will go down. And this matrix, the inverse of this A here, which is A inverse, which is this. So it's very simple. So the scalar will go down, any number multiplied by the matrix. If you put here the whole thing inverse, this one it will go down, and this one here. Now let's go down a little bit. 4. If you have A multiplied by B, and here inverse A matrix and B matrix, you will get B inverse multiplied by A inverse. The order here, we have changed it, so instead of AB, it will be B inverse A inverse. And also, if you have A, B, C, 3 matrices multiplied together, if you put the inverse, you will get C inverse, B inverse, A inverse. Let's give you example. I will write this A and A inverse here, so I will speed it up. Now let's consider B equal 5, 6, 7, 8. B inverse, the same formula which we have done it here. I will use it, so I will use this formula to find B inverse. So 5 multiplied by 8, which is 40, minus 6 multiplied by 7, which is 42. Now I have to swap these two elements. So 8, 5, -6, -7 equal 40 minus 42, which is -2. So I will write here -1 over 2. And here the same, 8, -6, -7, 5. Now I will insert this -1/2 to each element here. So -1/2 multiplied by 8, which is -4. Negative with negative positive, 1 over 2 multiplied by 6, which is 3. Negative with negative positive, half multiplied by 7, which is 7 over 2. Negative with positive, which is negative. Half multiplied by 5, which is 5 over 2. Now let's consider also C. 2, 1, 1, 1. And of course, we will use the same formula. So here, 2 multiplied by 1, which is 2, minus 1 multiplied by 1, which is 1. I have to swap these two elements. So here it will be 1, 2, -1 here, and here -1. I will put just the sign here. 2 minus 1, which is 1. So I will write here 1, so no need to write it, and it will be the same as this. Now let's multiply like this. So if you have A multiplied by B, so this multiplied by this. So if you have 1, 2, 3, 4, multiply by 5, this B here, it's like here, 5, 6, 7, 8. If you want to take the inverse of this, if you have A inverse and B inverse, you just put this B inverse here, because here B inverse, 7/2, negative 5/2. Multiply by A inverse, because B inverse multiply by A inverse, so I have to write it here. So if you have these two matrices, you want to take the inverse of them, you don't need to multiply them, then you take the inverse. You just put this, the inverse of the second matrix here, and the inverse of the first matrix after this one. And the same thing for this one. So let's go a little bit down. If you have, for example, the same 1, 2, 3, 4, which is A, then B, which is here in our example, 5, 6, 7, 8. And if you have C here, 2, 1, 1, 1. If you take the whole thing inverse, you can simplify it by just multiply these three matrices. So 1, negative 1, negative 1, 2, negative 4, 3, 7/2, negative 5/2, multiply by this one, negative 2, 1, 3/2, negative 1/2. So you can see it's very simple. If you have three matrices, you change the order, so you have to write the inverse of this one here, then the inverse of this one here, then the inverse of this one here. You don't need to multiply them, then you take inverse if you have all of these. Now let's go a little bit down. 5. The fifth property, if you have A inverse power transpose here equal A transpose the whole thing inverse. Let's give you example. Our A the same as this one. And the transpose of it equal. So to find the transpose of a matrix, you have to put the row as a column. So here 1, 2, it will be 1, 2 as a column, and here this row it will be here. So 3, 4 it will be here, 3, 4. You change row to column and column to the row. And as before, our A inverse as here, negative 2, 1, 3/2, negative 1/2. Let's go a little bit down. So here, if you have, for example, this A inverse here, so negative 2, 1, 3/2, negative 1/2. So if you take the whole thing, transpose as here, is the same as if you put the transpose this. So if you take the transpose of this A like here, and then you take the inverse. So if you take the A inverse here, if you put the whole thing transpose, it will be equal to the transpose here, which I wrote it here, the whole thing inverse. It's very nice property. 6. If you have A plus or negative, if you added or subtracted, B, it's not equal, and if you have here inverse, it's not equal to A inverse plus negative B inverse. For example, let's give you example. I will write A and B as we did here, A, B. So here I will write let, so I will speed it up to write A and B. So let's write this one here. So if you have A, let's say here 1, 2, 3, 4, and I will write plus or negative. If you put B here, 5, 6, 7, 8, and the whole thing bar negative 1, it's not necessary to equal to the inverse of this one here. 1, 3 over 2, negative 1 over 2, plus negative 4, 3, 7 over 2, negative 5 over 2. So it's not necessary to equal to this one. So you have to know that you cannot distribute it here, the inverse. Last property, A power negative n equal A n power negative 1 here equal A negative 1 power n. So the negative nth power of the matrix A equal to the nth power of A, the inverse, equal A inverse to the nth power. Let's give you example. The same as here. I will speed it up to write A and A inverse. Let's go a little bit down. Let's say you want to find A power negative 7. You can find it either A power 7 and the whole thing negative 1. So you will write this as 1, 2, 3, 4, and the whole thing power 7, and the whole thing here inverse. So you multiply by itself 7 times, then you take the inverse, or you can find it as this A inverse, then you take the whole thing for 7, so it will be, so you will use this one, negative 2, 1, 3 over 2, negative 1 over 2, and the whole thing power 7. Of course, you have to find this one first, then you take the inverse, or you compute the inverse, then you take the whole thing power 7. That's it here. Now let's give you example. find A if we'll use some property in this example, I2, which is identity, plus A, the whole thing, -1 equal 2, 2, 2, 3. So we want to find this A here, and they give you this, so you'll need to find this. And we know that I2 equal to 1, 0, 0, 1, identity with the size 2 by 2. Now let's try to find this A. So first, you can solve it as this. Think about it a little bit, pause this video and solve it, then see your answer with my answer. So here, power -1 here equal 2, 2, 2, 3. So what you can do, so you can take the whole thing inverse on both sides. Both sides you take inverse, so this inverse will goes with this, because -1 multiplied by -1, which is 1, as we have done it here. So -1 multiplied by -1, which is 1, which is as here. So we have used the second property, so this will simplify to I2 plus A, because this will disappear with this, equal the inverse of this matrix. And the inverse of this matrix, we apply the formula for 2 by 2. 2 multiplied by 3, which is 6, minus 2 multiplied by 2, which is 4. And here we have to swap these two elements, so 3, 2, -2, -2, -2, -2. Then here, I2 plus A equal, this simplify here to be 2, so 1 over 2. And I will write this matrix 3, -2, -2, 2. Then I have to insert this half. Half multiplied by 3, which is 3 over 2. Half multiplied by -2, which is -1, because positive with negative, negative. Half multiplied by 2, which is 1. The same thing here. Positive with negative, negative. Half multiplied by 2, which is 1. Half multiplied by 2, which is 1 here. And this will simplify by take this identity to this side, so A, it will be A equal 3 over 2, -1, -1, 1, minus identity, minus this identity, and I can write this matrix here as a matrix, not like this. So A equal, I'll speed it up to write this, minus identity, which is this one. Therefore, A equal, can put like this, 3 over 2, which is 1.5, minus 1, which is 1 over 2, because 3 over 2 minus 1, which is 3 over 2 minus 2 over 2 equal 1, because 3 minus 2, 1, and the denominator 2, so it will be half. That's why I wrote here half. Negative 1 minus 0, which is negative 1. Negative 1 minus 0, which is negative 1. 1 minus 1, which is 0. So that's it. We found this A, which is half negative 1, negative 1, 0. So if you substitute this A here and you take the inverse, you will get this matrix. So we found it. As you can see, it's very important to understand the property of the matrix inverse, and we have applied here. So it's very important to know these properties. In the next video, we'll do matrix transpose and its properties, which is similar to this video, and we will do a video to use matrix inverse properties and matrix transpose properties with plenty of examples to help you understand how to apply these concepts in different scenarios. Feel free to comment below if you have any questions or suggestion about this video. See you in the next video.